Hello everyone and welcome to the fourth video lecture of quantitative techniques. In today's lecture we are going to discuss the different techniques of measurement of correlation. So let us begin with today's topic. So there are various methods to measurement of correlation. These methods can be broadly classified into graphic methods and algebraic method. Under graphic method we have again two different methods. The first one is the scatter diagram and the second one is the graph method. On the other hand, that is algebraic methods, they are segregated into four different types. The first one is Karl Pearson's coefficient of correlation. The second one is Spearman's rank coefficient correlation. The third one is concurrent deviation method, and lastly the method of least squares. So in your syllabus you have the first graphic method, that is scatter diagram. Then under algebraic methods you have the first one, that is Karl Pearson's method of correlation. Then under the algebraic method itself you have Spearman's rank coefficient of correlation. So these three methods are there in your syllabus. So students, let us study in detail these methods. The first one is the scatter diagram. So what is a scatter diagram? If you look at the diagram or the figure, the graph that is given below, you'll very easily recognize that this is the graph that we had taken earlier in our video lecture 2. The same thing, whatever diagrams we have seen in that lecture, that is diagrams that are given below here, are nothing but all scatter diagrams. So what is a scatter diagram? A scatter diagram is a graphic method of measurement of correlation. It is a diagrammatic representation of bivariate data to ascertain the relationship between two variables. See, we are studying correlation, that is why between two variables, so that is why two variables, so we have bivariate data and we are trying to ascertain the relationship between two variables. Hence we are studying the correlation between two variables. Diagrammatically we are trying to put them on a graph paper. Two variables, that is x and y, we are putting on a graph paper diagrammatically. It is a graphic method. So this is nothing but a scatter diagram. Here you can see there might be one variable here. It might be, say, suppose advertising expenditure and sales revenue here. So if you are plotting these two variables on the graph, then we say that this is nothing but a scatter diagram. You can see these variables are plotted. There is no line, but it shows you an approximate idea whether there is correlation or not, and if there is correlation, is there a strong correlation between the two variables. So this is what we use scatter diagram for. So we shall take an example on scatter diagram. So problem, let's see if we can solve this. Given the following pairs of values, see, advertising expense rupees in lakhs, sales volume rupees in crores. So you can see there that there are some values given in advertising expenditure and some values are given in sales revenue. So probably in one of the year you had this much advertising expenditure and the corresponding sales revenue was this much. If in one of the year, that is maybe the next year, you spent this much, that is 5 lakh rupees, and you got a sales revenue of 2 crore rupees, and so on. Now what they have asked you is draw a scatter diagram, and also apart from scatter diagram, that is the graph, they have asked you a question, that is there any correlation between advertising expenditure and sales revenue? Is it positive or negative? Is it high or low? So all these thing basics we have seen in our previous video lecture. Now let us solve this problem. Scatter diagram, as you know, is a graphic representation, a diagrammatic representation, where one variable is plotted on the x-axis and the other variable is plotted on the y-axis. So you need a graph paper, and if you do not have a graph paper, you can use an ordinary paper, but in that case your scaling should be perfect. So let us start. After drawing the graph, you will get a graph like this. You can see here on the x-axis I have taken sales revenue in crores, and on the y-axis I have taken advertising expenses in lakhs. So see here, one corresponding value is 3. So if I go previously, sales revenue 1 and advertising expenditure is 3. Sales revenue is 1 and advertising expenditure is 3. So where will it meet? Plot a dot. Similarly, the next value what they have is advertising expenditure is 5 and sales revenue is 2 and 5. Okay, so sales revenue is 2, advertising expenses is 5. Sales revenue here on the x-axis, so sales revenue is 2 and advertising expenditure, see here, sales revenue is 2 and advertising expenditure is somewhere here 5. So I can draw it here and you can get the diagram. So this is the dot. Similarly, you can put other dots here, whatever as per the values. Then you will get something like this, that is dots. This is your scatter diagram, right? So you have drawn a scatter diagram. Now they have asked you whether there is is there any correlationship, that is correlation, is there any association between the variables. Now clearly from the graph you can see that these, as the values of sales revenue are increasing, as the value of sales revenue is increasing, the value of advertising expenditure is also increasing. So both the variables are moving in the same direction, both are moving up together. Okay, so in this case we see that there is a positive correlation. If they are moving in the same direction, that is with both are moving up together or both are moving down together, then we say that there is positive correlation. For example, we'll see this. If we fit a line through all these values, the best fitting line will be something like this. So this line is your approximate value where you have standardized these range of correlation. So clearly you can see that the values are moving from the left bottom to the right top. So we have positive correlation. Positive correlation. So first answer is yes, they are correlated, they are associated, and scatter diagram shows a high degree of positive correlation. We know that there is positive correlation. Is it high or low, they have asked. Now these values, if you see properly, what do you see from these values? These values very easily say that, see here, when you are fitting this line, they are not much away from this middle line. They are closely packed together, not on the same line, but they are very closely packed. They are not very away from each other. Hence we say that there is a high degree of positive correlation. High degree of positive correlation. Suppose if these values would have been like this one value, then one more value, then one more value, then one more value here, 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 we say that there is no positive correlation, or there may not be any correlation at all if it is very haphazard. But in this case we say that there is positive correlation, and as they are tightly packed together around a central line, hence we say that it has a high degree of positive correlation. The value of this correlation I do not know. We will get it by only algebraic methods like Karl Pearson's coefficient of correlation or by rank correlation method, but I can guess that the value is positive and it should be above plus 0.5 and between plus 1. So it is between 0.5 and plus 1 because it is high degree, so high value, positive side. So the value is definitely close to 0.6, 0.7, 0.8, somewhere in this range. 0.7, I think 0.7 or 0.8 it might be. So to find the exact value you have to use the other algebraic methods for this. So with this we shall end today's lecture.